Hello all. So this is my first playlist of prefix sum, and what we'll be covering today in this first video of this first playlist will be prefix sum, basically 1D prefix sum and range calculation. Basically, most of these two topics will be quite easy. It will be mainly used in calculating some other kind of questions based out of these questions. After calculating prefix sum, if you have to calculate some other thing, you'll do it in the less time complexity with this method. Okay, so just understand this. It will be simply basically what is prefix sum is. Prefix sum is nothing but to calculate the sum from 0th index to ith index. Okay, where this I lies from anything between 0 to n, and our whichever question nums array will be given, it will be basically 0 based index. So this is the basic form of question which you have been provided. Okay, let's start with simple question of this. Let's say you are given this nums array which is 5 4 3 7 6 8 and 1. Okay, and you have to calculate the prefix sum out of this. Now in two ways you can do. If you have to return the answer vector or the prefix sum vector out of this, then you have to apply for the zero based indexing. That would be easy. But you have to, if you have to just use this prefix sum to calculate something else, you can use one based indexing, because you didn't need to apply some special conditions and check out of it and all those stuffs. We'll go for both these things. Okay, let's say you have to do it first with zero based indexing. Now for zero based indexing, what you will do is your array is your, let's say, prefix sum array out of it. So here you will create an array vector of size n, okay, and everything else will be 0. So this is to initialize whole vector of size n with 0, and you will do array of 0 as simply nums of 0. Okay, first value you have put as it is over here, and now what you have to do, you just run one loop from I to n and just calculate array of I as array of I minus 1, whatever you have calculated until I minus 1, that sum plus current sum, current index value. So nums I, and it's done. Okay, now for one based indexing, what you have to do for one based indexing? For one based indexing, you will initialize this array with n plus 1 and 0. Okay, so now no need to do this step. You can directly use I is equal to 1, but here you have to do until I less than n, less than equal to n. Okay, and same formula, array of I is equal to array of I minus 1 plus, but as this array is one based index, but this nums will always be mostly 0 based, whatever you have given in the question, just read it out. Mostly it will be 0 based only 99% of the time. So this you have to do I minus 1, because this you are starting from 1, but this you are referring to 0, so you have to do I minus 1 every time. Yep, that's it. This way your array which is be calculated as the prefix sum will be done. So let's say I'll do it with 0 based as of now. Then I'll put 5 as it is. Now what I have to do, for I is equal to 1, this 0th index array value which is 5, and this 1 based index, this value 5 plus 4 will be 9, and then this 9 plus 3, 12, and then this 12 plus 7, 9, and then this 19 plus 6 will be 25, and then this 25 plus 8, 33, and 33 and 1, 34. So this way your prefix sum will be filled. Okay, simple. Time complexity will be order of n. Space complexity, as we have created one extra array of size n, it will be order of n. Clear? So this is a simple formula of it. Okay, this way also you will get the same answer, just 1 0 added over here extra, and it will be n plus 1 size. Yeah, that's the only difference for one based indexing. Now we have to use this approach and we will calculate this range calculations, which I've told you. Now what is range calculations? Let's say you are given this nums array only, and also you are given some q queries. So I'll take another nums array. Let's say this 5 6 2 3 1 7 and 4, and you are given some q queries of form L comma R. So until now, for the normal prefix sum, what you have done, you have calculated the sum from 0th index to ith index until ith index. Now what do you have to do? Now you have to calculate the prefix sum or sum of this nums from lth index to rth index, and this L will always be less than equal to R, and both will be in the range of 0 to n only. Okay, so what you will do, let's say you will be given two queries, 0 to 3 and 2 to 5. So what you will do, you'll start from 0 for first query, you'll start from 0, you'll add 0 for 1, 2, 3, 5 plus 6 plus 2 plus 3, and whatever will come you'll return. For second query, you will again start from 2th index, second index, 2, 3, 4, 5. You'll add these four values and you'll return. Okay, so how much time complexity? This is the brute force approach. And it will take order of n cross q. Why? Because you have to run full array, nums array in worst case. Let's say if it is 0 to 6, then you have to try from 0 to 6 full, all the indexes. So you have to run nums array every time. How many times? Q times. So it will be n into q. But with the prefix sum, what we will do, we will pre-compute prefix sum. What do I mean by pre-compute prefix sum is, let's say I'll be given this nums array, which I've shown just on this front page, 5, 6, 2, 3, 1, 7, and 4. Okay, so what you will do, you will pre-compute prefix sum out of it. So you will create one vector, let's say array vector, out of this, which will be 5, 11, 11 and 2, 13, 13 and 3, 16 and 1, 17, 17 and 7, 24 and 28. So you have calculated this prefix sum, which we have learned just now with the formula. Pre-compute it. Pre-compute it means we will calculate it and store it here. That's it. Now you will go to Q queries. Okay. So let's say your first query is nothing but 0 to 3. So what now you have to do is, simple formula is array from L to R. If you have to do sum from L to R, what you will do? You will take prefix sum until R. Until R means it will be 0 to R only. Here this array is based out of, I have told you very initially only, that what is this? This is from 0th index to ith index. So array of R will nothing but 0th index to rth index, your sum. It will be stored here, and you will subtract the sum came until L minus 1. So then it will have the sum from L to R only, fixed. Okay, so let's say you have to calculate for 0 to 3, then what you will do? You will do array of 3 minus array of, now 0 minus 1 will be minus 1, and this will not work. Okay, so this is, as this is 1 based indexing, this array is 0 based indexing, sorry. As this array is 0 based indexing, you have to check this every time. If L minus 1 is greater than equal to 0, then only you will subtract this array of L minus 1, otherwise just to do array of R. Okay, if it is not greater than equal to 0, just do array of R. If it is greater than equal to 0, do array of R minus array of L minus 1. Okay, here as it is not, so we will just do array of 3, which is nothing but 0, 1, 2, 3, so it will be 16. But if at all you have calculated this array of 1 based indexing, then what you have to do? Then you have to just increase L by plus 1 and R by plus 1, because this L and R will be given in 0 based terms. So you have to increase them to 1 based terms, and then you have to apply this formula without checking also. It will be always satisfied. Okay, and let's say second query is nothing but 2 to 5. Okay, so what you will do? Array of 5 minus array of 2 minus 1 will be nothing but 1. So array of 5 here will be 0, sorry, here. Okay, this is 0 based indexing. 0, 1, 2, 3, 4, 5, which is 24, minus array of 1 will be 11. So this is what? 13. Now if at all we'll calculate from here also, this is second, third, fourth, fifth. This 4 we have to take. 2 plus 3, 5, 5 plus 1, 6, 6 plus 7, 13. You will return that. Okay, so only once you have to pre-compute this prefix sum, and now you have to apply this formula of array R minus array L minus 1. If you have calculated this 0 based, if you have calculated this 1 based, increase L and R by plus 1, and then same formula, array of R minus array of L minus 1. Okay, and this will decrease your time complexity to order of n plus q. Why? Because order of n to calculate this prefix sum, and now you have to just run the q queries, and you will calculate in just one formula, an order of 1. So order of q will be added to this, it's not multiplied. You are not calculating this lth to rth index every time, every q times. Okay, so it will be n plus q. Space complexity remains the same as you are calculating prefix sum and storing it in some array of size n. Then it will be same order of n stored it as. Okay, fine. We'll quickly do the sum of this. One question of this is the same type of question I have on the lead code, so we'll move on to that and we'll do that. I will give you the handwritten notes, not this. I've made the fair notes. I'll give you that in the description, and I have also given this question which we'll be solving now, and one another question of code forces which is similar kind of this based on this range calculations only in the description. Check out that, solve that both the questions before the next session. Our next session will be on the scanline algorithm. Okay, so just to brief you out, scanline algorithm is the famous algorithm of the prefix sum. It will be asked by most of the companies. Okay, and you will learn a lot of variations in it. Okay, so let's move on to this question. This question we have given the integer array nums, and you'll be given two indices, left and right, and you have to calculate the sum of elements as we have discussed from left index to right index via this sum range function. And this num array is nothing but the which initializes the object with your nums. So we'll just create one prefix sum vector. Okay, just to clarify, whenever you will create a vector outside of the function or class like this, you cannot assign the size to it. You just have to create it. After coming here, as we do not have to return this array, I prefer one based indexing over here. So I'll just resize it with this formula resize, and I'll make it n plus 1. Okay, and now we'll pre-calculate or pre-compute this. So for int I is equal to 1 less than equal to n I plus plus, what I'll do is I'll do prefix sum of I is equal to prefix sum of I minus 1 plus nums of I minus 1, only because nums will be 0 based. So in this way my prefix sum is calculated. Now my prefix sum is 1 based, and this left and right indexes will be given in the form of 0 based and in relation with the nums array. So what you can do is while returning, we'll do r minus l minus 1 normally. So here we'll do r plus 1 minus l minus 1 plus 1, which is nothing but l. Okay, and that's it. We'll try to run and see it whether it's done or not. Uh-oh. Oh, it's prefix sum. Fine. So this way it will be done. Okay, stay tuned for the next video. It will be scanline algorithm. Mostly two videos I will take on the scanline algorithm, and it's a very important topic. Okay, goodbye, have a good day.